We'll do the next two pages together. So 11 says, big F is a function defined by all real numbers, or F prime is positive, F double prime is positive. Which of the following could be the table of values for F? All right, so we need to see numbers that are increasing at an increasing rate. All right, so if we look at our choices here, -3, -4, -6, -9, those numbers are decreasing, so A is out. B, -3, -1, 3 and 19, that's okay. C, -3, 0, 3, 6, that's okay. D, we see -3, 5, 11, and 13, that's okay. E, we see -3, -4, that's a decrease right there, so E is out. Okay, so we now know we have B, C, and D as our three choices. We need to see increasing at an increasing rate. So let's look at the change. We have a change of +2, and then +4, and then +16. So that is increasing at an increasing rate. So it does seem like B is going to be our answer. Let's just check real quick with C. Change in 3, a change in 3, a change in 3. So this is increasing at a constant rate. And then D, we see a change of 8, and then a change of 6, and then a change of 2. This is increasing at a decreasing rate. So yes, so C and D are both out, and the answer is B for number 11. For 12, we have this table up here that tells us about F, F prime, and F double prime. F is twice differentiable on the interval from -2 to 2 and satisfy the conditions in the table above. If f of x is equal to the f of the opposite of x, what are the x coordinates of the points of inflection in the graph of f on this interval? Okay, so this is a little tricky here because we see this right here. This means that f is even. All right, and you may not have talked about even functions, odd functions in the past, but if we have an even function, that means that there is symmetry with respect to the, or with a WRT, with respect to the y-axis. All right, so it's a mirror image over the y-axis. Right? So what's happening here? All right, well, we've got over here, here's 1, there's 2. We have a function which is positive and then negative. We have a derivative which is always negative, which means the function is always decreasing. And then we have a second derivative which is negative and then positive. And we're looking for points of inflection. So we see the change of sign here. That's pretty big tell that there is a point of inflection at 1. But let's draw the graph here. So we need a function that's positive and then negative, always decreasing, and then negative second derivative means concave down, positive means concave up. So we are looking at maybe something like this, concave down and then concave up, always decreasing, positive and then negative. Now because we have symmetry with respect to the y-axis, that means we have the same thing happening on the other side. So we're getting a graph. Oh, that was not good, but you get the general idea hopefully. In both cases we see that we have a point of inflection there at 1 and then at -1. So there's 2 points of inflection, but really we didn't even need to draw the graph. We can see this change of sign, and if we know that this means that we have the symmetry, then we can see that we're looking at -1 and 1, so the answer is D. 13, we have this graph. What's the absolute min on the closed interval from -2 to 1? So that means we have a candidates test going on, x and f of x. We already know 2 of the candidates are going to be -2 and 1 because the endpoints are candidates. We need to now check out the critical numbers, which will occur when g prime is equal to 0. So first we get g prime. Then we set it equal to 0. All right, so we got this quadratic that's equal to 0. So I see 12, 6, and 6. So it looks like I can pull a 6 out, right? I can make this 2x squared plus x minus 1 is equal to 0. And obviously 6 is never equal to 0, so I'm really just looking to see when is 2x squared plus x minus 1 equal to 0. That means we have to factor it. 2x squared, the only way that we can get 2x squared is with a 2x and an x. And the only way we can get -1 is with a +1 and a -1. But we need the middle term to be plus x. So I think we want a minus 1 here and a plus 1 there. So now if we were to quickly distribute this, 2x times x is 2x squared. 2x times 1 is 2x. Negative 1 times x is negative 1x. And 2x minus 1x is x. And then negative 1 times 1 is negative 1. So this checks out. This is a correct factorization. Now we cover them up one at a time. And we see that x could be negative 1, which is in our interval. And then we can also see, 2x minus 1 is equal to 0. So that means that 2x is equal to 1 and x is equal to 1/2. 1/2 is also in our interval. So we have 4 critical numbers, the 2 endpoints and the 2 critical numbers. All right, so we got to check these out. We are looking for an absolute min. So we're looking to see which of these is the smallest value. So we're going to take negative 2. We're going to plug it back into the original function. All of these candidates are going to go back into the original function. So that means we have 4 times negative 2 cubed, which is negative 8, plus 3 times negative 2 squared. Negative 2 times negative 2 is 4, minus 6 times negative 2, plus 1. So 4 times negative 2, 4 times negative 8 is negative 32, plus 12, plus 12 more, plus 1. All right, so negative 32 plus 12 is negative 20. Negative 20 plus 12 is negative 8. Negative 8 plus 1 is negative 7. Okay. Well, you know what? I can use my test-taking skills here and stop. I want the absolute minimum value. Look at the 4 choices. What's the smallest choice? Negative 7. We just found negative 7. So no matter what happens here, doesn't really matter. Negative 7 is the smallest value that we just found. We can't get any lower than negative 7. We're looking for an absolute min. There's our answer. And then number 14, a rectangular area is to be enclosed by a wall on one side and fencing on the other 3 sides. All right, so here's our wall. Here's our rectangular area. With the fence is there in the pencil. If 18 meters of fencing are used, what's the maximum area that can be enclosed? Okay, well, we've got x and y, and we know that area is equal to x times y. But we also, well, we can make that y and we can make that x because we have ourselves a rectangle. And we know that 2 x's and y, that's our perimeter. Our perimeter is, well, technically our perimeter is 2 y's and 2 x's, but the wall doesn't count because we're just looking for the maximum. We only have 18 meters of fence. We don't have any fence on the wall side. So we've got 2x plus y is equal to 18, right? The amount of fencing that we need is right here. It's 18 meters of fencing, and it covers 2 x's and 1 y. All right, so we need to find the maximum area, which means we need the derivative of area, and the problem is we've got x and y right now. But if we do a little work here, we can subtract 2x from both sides. We see that y is equal to 18 minus 2x. So by substitution, area is x times 18 minus 2x. Right? We sub y out. We sub its equivalent in. Now we can distribute, oops, let's try that again, 18x minus 2x squared. Okay, and we want a prime. We want to find when a prime is equal to 0, because the maximum is going to happen when the critical number occurs. The critical number occurs when the first derivative is equal to 0. So we get our first derivative. We have 18 minus 4x. We want to set that equal to 0. That gives us our critical number. All right. And what? We add 4x to both sides, so 4x is equal to 18, and x is equal to 18 divided by 4, which is 9 over 2. All right, so what are we looking for here? We are looking for the maximum area. We only have one critical number, so we don't really have to do a first derivative test. We could, but we'll save some time here. We only got one choice, so this is it. But that's the x value. We're looking for the maximum area. Area is x times y, or x times 18 minus 2x. And we know that x is 9/2, so if we plug that in, so we have 9/2 times 18 minus 2 times 9/2. Well, 2 times 9/2 is 9. 18 minus 9 is 9, so we have 9/2 times 9, so that's 81/2. So our answer is E.